Hi, I'm Shadow, bringing you part 4 of our Programming with Shadow video. Today we're going to talk about repetition. So in the past we looked at conditions and we're going to expand it now. The idea with repetitions that sometimes you want to do things multiple times, like maybe you want a program that can count something, or maybe do something a certain number of times or until something happens. All that's where repetition comes in. So let's begin. Do a little motivation here. Let's say do counting. So we could, if we wanted a program that prints out some numbers here, we could do this, but it would become very tedious very quickly. By the time you got to here, there's got to be a better way, and there is. That is repetition. Show terminal. I press control the number, the beside tilde, the number beside 1. Now it'll load. Do .NET run. Now we'll print 1, 2, 3, 4. So that was all right. Well, if it'll run, that was all right because that's not many. Say we want to do more. Maybe we want to do 1,000. Maybe I didn't. Should have been it. One more time. There we go. So yeah, so 4 is not hard. Let's say we want to show 1,000. Suddenly that becomes unreasonable. Let's look at a better way. So C# or the primary way, well, one of the ways to do this kind of approach is by looping. Looping literally just going through and doing something so many times. There's several different ways to loop. We're going to look at 3 today. First is the for loop. Let's do int. I'm trying to think of what's a good name for this. I is sort of canonical just because it's what people use, but not necessarily a good name. A lot of times you can have a better name. We'll talk about each part here. So let's say 1,000. And out today. So this will do that almost. There's actually a subtle bug here we'll look at, but here we'll post numbers. We'll go from maybe all the way to 1,000, but it stops at 199. That's from our if check here, and we can adjust that. I wanted to see the other end. Let's make this 10. So let's do it on a smaller scale just to make it easier to see. So there. So most of the time in programming stuff, you'll hear it as being called zero-based. It means a lot of stuff will start at 0. In this case, it probably don't want it to. So that's what these sections are. Let's do a comment. So int I equals 0. This is the initialization phase. That tells you where you're starting on your loop. Next section, I less than 10, is the conditional phase. So that's where you're going to, what condition you're trying to reach. Finally, I++, this is the, I want to say incremental, you can go down as well. So that's the 3 parts here, and you'll find most loops, they have something here, some kind of change here that gets you to get this condition changed. So for loop's like a really easy way to combine all these, and it's the most common you'll see. And it can be tricky to remember. I remember helping your students with this one a lot. is like it was hard to remember which one goes where. So it starts with initialization, then what you're trying to check, and then how your step. Rephrase this. Incremental / steps. Yep. So I'm doing just +1 here. You could do other things here, like it doesn't have to be just +1. You could do I plus equals 5. We're going to count up to 5. Let's go. That will do the same thing, but we'll count by 5s instead. So I said it's not counting the last one. That's our conditional here. If, as we remember last time, there's other ones besides less than. You can also do less than equals. Now it'll add the 50 in there. So this shows the point though. Maybe we don't want. What if we don't want 0? What if we just want 1 through 100? So this will get 100, but still going to start at 0. So the initialization can be something else as well. So I'm going to do 1 here, and now we'll have our 1 to 100. Again, probably too many to show, but starts at 1 is the 100. Loops can be really powerful. That's just a few of them. What if you wanted to do a lot more? You can. Let's do max value. This one I'm probably going to cancel because it'll take a long time, but this one's long enough that the loop's already finished, but now it has to go print out all the numbers. And that's the slow part. It's actually doing the printing. Go ahead and stop this. Max value is 2 billion change. Let's stop this. Control C. There we go. Let's make an adjustment. Move it back to something more reasonable. So in programming, loops can be classified differently. This is what's called a counted loop. Counted. Fail. A counted loop. That means you have some number you're starting to, and you're counting up in values. These are very common. These are probably the most common in my field, at least. So you're counting, right? You're counting some number of positions. There's also uncounted loops. Look at an uncounted. Let's add a console.write line here. Let's do for loop. That'll do. Let me make it a little. Next, we have an uncounted loop. So, while loop and uncounted loop. Alright, so while loops, or for loop and while loop are very similar. The difference is that while loop looks simpler, but they still have the same 3 parts. Let's do, I'm not going to use I here. Or when you're doing your variables for these are called loop counters. So they're always going to just be, I don't know, like if I try to access I out here, let's do that. Do that first. So this looks like this is exactly the same line. This one's not going to run though. That should fail to build. The reasons for this is when you do, there it goes. Expected to get a semicolon. Wait a minute. I did. That is not the error I expected to see. Let's try again. Other one. Apparently can't remember my basic syntax. One more time. There we go. The name I does not exist in the current context. So I here, when it's declared inside like this, it's only concerned with being in the braces here. It won't show up outside. We can fix that if we wanted to. Like we could do int I equals 1 equals. We don't even need to initialize it. We initialize it here. Now, whatever I is at the end, we'll see it'll print 10 twice here at the end of this loop. No, it did not. It counted as 11. Okay, so that's because of the equal. Let's move it to 11. Now we should see 11 here at the end. Right? The same thing. So when it does the loop, you're seeing the processing now. So it starts at I, first loop through. You see the 1, checks that, and then adds 1. Does that and does that, and the 10th one, it sees 10 is less than that, does the loop, prints 10, then goes back around, increments, so I++, that gives you 11 here in I. Then it checks I, which equals 11, is less than 11, and this is false. It's false, and then you're done. That's where this is printing out. So one other thing you can do, and I don't see this very commonly, but occasionally, these sections don't technically have to be there, but you can, if they're not there, you're more likely to run into problems. That problem's called an infinite loop. Here, we'll come back to this uncounted in just a second. Infinite loop. So an infinite loop is one that doesn't. Just get rid of this. So now we're just constantly adding up, and you'll see here that when we run expect to see, it'll just keep counting. That's because we didn't tell it a condition. So the condition right now is nothing there. So while nothing's true, going, or bad syntax. While there's nothing there, there's nothing to fail the condition, so it's always true. That's what I'm trying to get to. Occasionally you want that. Here, let's stop this and let's show something else. Let's do it. If I equals, say, 1, 2, 3, 4. I just did 1 equals, let's do 2. Let's do a break. The break says if you're in a loop, let's stop the loop, break out of the loop. So we're going to see when we equal this, in fact, move it up. So here we won't even count. Here I should have done 1, 2, 3, 4. So let's let it count up just a second. Then when it hits 1, 2, 3, 4, 5, there we go. And this last one comes from this outer loop here. Make it a little shorter, and we'll show that again. Let's do 1, 2, 3, 4, so it's a little quicker. This here, we'll break it out, and you see it's there. All right. So, not technically required. I would caution against not putting your values in though. Usually, I want to have a reason to do that instead of just to do it. Let's do equals. Get rid of this. Another thing we can do so here, without this, do another one. Do I mod 2. If we remember from earlier, the parenthesis sign means modulo 2. Let's do equals 0. So this is saying if I is divisible by 2 and there's no remainder, break. But let's not do break. Let's do continue. Continue. Continues like break. Break breaks you out of the loop. Continue, on the other hand, just says, okay, I'll hit this, skip this. Now if we do this, we're going to see it counts by 1, 3 odd numbers, so 1, 3, 5, 7, so forth. We run, course, I forget this guy again. So now it's counting by odd numbers. There we go. So that's a continue and then break. Now let's get back to the counted and uncounted loops. So the while loop has all these same pieces and has similar rules. So I is a common one there. Another one common for loops is a J. It usually is I, J, K, and L. If you have more loops than that, you probably need to think what you're doing because it can get really slow really quick. So while J, let's just do J is less than 1,000. That's basically what we'll do. Let's do less than or equal so it matches what's above there. I guess we have to start at 1 as well then. Let's do 10 just to make this seem better. This 10. Now line J. Now we expect to see the same thing for both of these. But we're not going to because of a mistake. So the three parts of the loop were the initialization, the condition, and the increment. We don't increment here, so we would need to do J++. I see that the most common thing when you do a while loop to forget is to add that. And that's usually the symptom is you get in the infinite loop and it just keeps going, and you have to press Control C here, like I did here, to get out. Now if we do it though, we should see 1 through 10. Again, initialization, condition, increment. So right now this is simulating a counted loop, but it can be uncounted as well. Let's say I'm trying to think of what's a good way to do it. Let's do a string here. Console.write line. Enter a number. String console.read line. Let's do like this. So now while int.parse try-parse while try-parse my number out var j. Do int j. Do what? Do it the other way. While it doesn't. So we'll talk about what this means in just a second. Let's try this. So now console.write line. My number is let's try this. So what I've tried to do here is ask for a number, and then I'll enter a number at the terminal. If the number isn't actually a number, so whatever the user inputs, they could do an A or whatever. So here we're going to say, okay, an A, this try-parse fails. We remember from earlier. If the try-parse fails, it's going to say, okay, it's failed, so it is not a number. So then try it again. Let's see if this works. Got another semicolon right here and right here. So if you've used another IDE, we're using Visual Studio Code right now. If you use the warrant, we'll ignore that one from. Enter a number A. Right, well, it turns out A wasn't a number, so another B, C, 3, 4, 3. There, my number is 3. What we've just done here is we don't know how long this loop's going to run. The user could keep typing in A forever if they wanted to, and the loop's going to keep running. That's what makes it an uncounted loop. What we did there, though, was we've now checked our input, so we're saying we expect this to be a number, and while it is not a number, that's what this try parse is doing. It's checking if it is a number. So while it's not a number, try it again. That's an uncounted loop. We can do better than this, though. Right now, this is duplicated. So you're asking them for something and getting it back. We're doing it again. Both of these have another condition. These are both console.write line. These are pretest loops. So the idea of pretest loops is you check your condition before the loop executes. So here for this, so the first run, so I equals 1. So while, or so if I is less than 10, do this and then increment. So then I is 2. Is 2 less than 10? Less than or equal to 10? It is. So write the 2, increment. Same thing with while here. So get my number. Get my number is probably better. I should say something else here. Number will do. I should use J here though. It'll be the same answer, but it should have used J here. The while loop's the same way though. It's a pretest, so I got my numbers here. So while this fails, do this. They enter B. While B is not a number, do this. While B is not a number, do this. These are both testing before. There's another condition that does after, however. Let's do console.writeLine post test loop. I see these less frequently. In fact, most of the time I see them is to do this exact condition here, to check an input and keep checking it until they give you the right answer. Let's do that. So in C#, this is called a do while loop, and you'll see why. So do this. Console.write. Should just copy what I have right up there. Right. Enter a number. Let's call this one string user input. So user input equals console.readline. So now down here, you'll see this in different ways. I'm going to do it like this first, but I'll show you another way here in this. While int.tryParse user input out int k. Console.writeLine user input is. Let's do it like this. We used concatenation before. Let's do it like this. Is k. This is string interpolation again. It does the same thing as here, different word, but same outcome. Now this is a post test loop. So this says do this, then after you've done this, check your condition, and then keep going. This one's a little odder. So your initialization's here, conditions here, but your increments in the center. Let's add that. Initialization step. I was calling this increment. Let's call it increment slash step and condition. So this one's slightly different, but we'll see here. It's the same outcome. If I can get the semicolon right here. But what I was saying, in VS Code, it's very basic. In other editors, if you use actual Visual Studio or other ones like Writer, you'll find that it adds these most of the time, so easy to forget. Still forgot one. Or did I forget another one? Just forgetting them all over the place. Up here at the top. Yeah. Right now I've got my microphone blocking part of the message, so I'm having to look over to the other screen. Build failed. Okay, does not. Oh. This case here. So my J here, this one works, so J is accessible outside of the loop. I believe. Let me make sure that's the case. Okay, so here it is. So maybe I'm actually wrong on this. Yep, I am wrong. Okay, so you actually do need to do this outside of the loop. So let's do it like this. So int J. So what that was telling me is here, the name J does not exist in the current context. Again, my microphone's blocking part of that, but that's telling me that what I was trying to do there, it's only available inside inside here. So inside this, it's called a scope, inside the while loop, basically. There we go. Enter number 5. There we go. So when I declare it inside here, I guess it has to stay inside, which makes sense. I should have checked that before I started. I didn't think of doing it until inside here. But what that allows you to do, or what that allows you is, if it was inside there, I could use it inside here, and then have another J outside if I needed to. But most of the time, you don't need to do that. Most of the time, it's best just to use one variable and to separate them another way, and we'll see another way in maybe next lesson. Maybe not next. But yeah, so that's what that warning's fussing about. So if I do come back here and comment all this, K is the same thing here. So I want to do this. Do int K. Now these should work. Do while loop, enter an A, enter a 5. Now we're in a post-test loop, and I should have put do while, but this is my do while loop. So here it hasn't actually checked what value I put, so let's put a K. K is not a number, so U. Let's try 8. There we go. User input is 8. So now we have simulated them two. So these two are both uncounted loops, and even though you can simulate them as counted, usually if you want to counted, use a for loop. It's probably going to be cleaner. So try something else. So this is how I've usually seen a do while loop used. Occasionally you'll see them written like this. Doesn't matter. That's exactly the same. It's just whiles on the same line. In fact, may even be more valuable. Do whichever the rest of your code does, and you'll be fine. Let's do something else now. Let's trying to decide if I want to do it here in this program or not. Let's do out everything. And the keystroke to comment stuff out is holding Control and press K, and then Control and press C again. Do that again. That's how I'm commenting stuff quickly. To undo it, you go to wherever you want and press Control and then K, Control U. You can see it showing down here. Control K was pressed, waiting for a second. Control U. That's how I'm doing that. I think you can also do Control K backslash. Control backslash. There we go. Control I'm saying backslash / question mark. Yeah, / yeah. So if you do Control / here, it toggles the commenting. And I don't use that one all that much, but it's just because I learned the other one well before. That can be easier just to toggle it. That way you don't have to remember 2 separate keystrokes. I've learned the other one though because my IDE I regularly uses it supports that by default. So that's the one I got used to. And I think when I started, Control / wasn't toggle. It did something else, but you can toggle it as well. If you ever need to look at shortcuts, by the way, there's a show all commands here under Help, all commands, Help, keyboard shortcut. That's what I'm looking for. I'll open your browser and take you to some of the keyboard. Maybe. I do. Yeah, and that's hard to read, but you can zoom in and look at it, and it has all the basic keystrokes. So if I look in here somewhere, there's going to be Control / somewhere. Right there, toggle line comment. So you can use that though. You can use the shortcuts here as much as you like. I'll try to mention the ones that I use, but I will forget. Like I would never remember keyboard shortcuts. I'd always just go to Help. One of them I press all the time is Control S, and I just do it so frequently. It's that save here. I've got it configured so it saves off, but a lot of times what I'm actually doing is I'm pressing Control S in the background. And I'm just so used to doing that, I just don't think about it. But those are keyboard shortcuts. So let's look at a new topic though. Let's do I'm wanting to do a loop both ways. Do it like this. Do string call it let's call it palindrome because that's what I'm going to try to do. Let's do a palindrome. So a palindrome is something that's spelled the same way both backwards and forwards. So here, if you look at this, if you spell this forwards, race car is the same as if you spell it backwards, which is also race car. Well, let's do a little program here to check it out. And I'm having second thoughts. Let's do it like this. Let's come down here, do cd dot ls. So I'm going to put it in here. Let's do Nectar palindrome. Let's do it in its own project. So .NET new console. Yeah, I had second thoughts. I'm going to keep this workspace sort of a little clear. So let's undo this. Let's undo my commenting. Let's get a comment. Okay, let's open this one here. So we're now in palindrome. So palindrome, what you can do is code dot. It should open me that workspace. It did. We got a new template program here, so add that air race car. Okay, so what I want to do is go backwards and forwards here. So we can think about this two ways. We can think of it as counted or uncounted, and it doesn't really matter here. So I'm going to do the counted loop because that's what I first thought of when I seen this problem at first. But probably actually maybe a little more logical using while loop here. Let's do the while loop. I think it is logical. Let's create two variables. So int start equals 0, int end equals. So here's the thing. So what we're going to do is we're going to mess with the values here in this string. How do we figure out how long this string is? We count the variables, like the letters. So you start at 0. So 0, 1, 2, 3, 4, 5, 6. We could do that. You can also do this, however. So we can do palindrome.length. So now if we do console.writeLine, start is start and end is end. Now if we do that, control tilde. Tilde is the character beside 1 on the keyboard. Run. Now we expect to see 0 and 6. It's 7. So this length did not do what we thought it did. The length is actually the count of all the letters. So it's saying there's 7 letters. What we're going to want to do though is be one off from that, because the numbers are going to start at 0. I'm going to add a minus here. And sometimes you'll want this, sometimes you won't. It's all context for what you want. So now we get 1 through 6. Period here at the end. Completely unimportant. I'm going to add it anyway. What I want to do now, though, is I want to say, okay, we're going to index in the string. So I'm going to say palindrome at position 0 equal to palindrome at position last. End. Start and end. Position at start and end the same. I'm going to add 1 to start, subtract 1 from end. We're going to keep going until they're equal or not. If they're all equal, we're going to palindrome. Let's do that. So while start is less than let's do less than end. So if it's less than end, it's fine. If end and start and end are equal, however, which will be on the E, then this doesn't work. So the while condition is no longer met, and we're done. If they're both on the same letter, it's the same. It's fine. So let's do add one more variable. Do full matches equals true. So I'm going to use matches to say, okay, the numbers match, and we're going to assume it's true until it proves it's not. Down here below the while loop, we'll fill up the while loop in just a second. If matches console.writeLine let's do is a palindrome. A semicolon. Else is not a palindrome. There we go. Now we need to fill out the while loop here. So what we want to do is we want to index into the string. So to do that, we do this. So if palindrome at start. So to check that, you use these square braces. That says index into the string at this position. So right now it'll be 0, but we'll fix that in just a second. So if start equals palindrome at end, what do we want to do in this case? If they're equal, we're good. If they're equal, let's do this. So if they're equal, start plus plus and end minus minus. So that's going to shrink the shrinker window here. So then we would be looking at position 2, position 5, 1 and 5. We start at 0. So if they're not the case, though, let's do it else. Else matches equals false. So here we proved ourselves wrong. So our assumption here that it's going to be a palindrome is proven false. At that point, if it's proven false once, we're not going to ever change matches, so it's never going to affect the thing down here. If we're proven false, we can just say break. And we could say continue here, like this would work. Perfectly fine. They omit this here though, and it's actually clearer to omit this because it's just going to say, okay, we're done. Go on down, next loop. We'll do it like that. And the condition's got to be one of these two, so we also don't have to worry about that. So it's either always going to be, it either matches or it doesn't. So there's no other condition in that case, so else if is all we'll ever need. In fact, we could get rid of it if we didn't want to. Like we could do it another way, and we'll look at it in just a second. But I believe this will tell us that race car is a palindrome. So let's do race cars, so something very similar, but it's not one. Not a palindrome. Very nice. So let's do another one. I can think of another palindrome. Let's look up one actually. I'm not thinking of a good one right at the moment. There we go. There's an easy level. Level is a palindrome. There, there. We've sort of got this, and notice I didn't have to adjust the length, even though we used a smaller word. Everything just worked. And I would say this is perfectly fine. This would be sufficient in my opinion. Really wanted to, we could do something else here. We could clean this up, and this might be cleaner, but I would say it's about the same in my opinion. Let's invert this check here. I would say this is probably less clean in my personal opinion. I would stick with what we had first, but we could do this route as well. Do control. So what I want to do is I want to toggle. Like I said, I'm not used to toggling, so control / again. So let's do matches again. Matches equals false. Right, I misspelled false. So now start plus plus end minus minus. So I postulate this is the same thing. If we do a .NET run, the level is a palindrome. Race cars is race car will be as well. So what this is we now have the same conditions inside the loop. It's just a different way to think about it. But here we're saying if the letters don't match, and break out of the loop. It's exactly the same condition here. We don't have the else at this point though, because we really don't need it. The break here goes ahead and exits the loop. We don't need it here, and otherwise this is just falling through anyway. So the hypothesis here is that is the same thing as we just seen it actually is. All right. So I believe that's all I wanted to do. So little example here of solving a problem. So checking if a word's a palindrome. We may want to say we could take the user input and do something with that. But so let's do a recap of what we've learned. So today we have seen three forms of loops in C#: for loop, while loop, and the do while loop. Doing so, we've learned some terminology related to the loops. You can have counted loops, uncounted loops, loops that have a pretest, or loops that have a posttest. We also seen how you can use loops here to do some input validation. We'll see that that's the most common way I see to do this loop in particular is for this reason, but you can use other things for it and it'll make sense. That's the most common thing I've seen to do. We also looked over here at this second project. We did just a little simple thing to check if a string is a palindrome or not, so if all the letters back and forth are equal. In doing so, we learned you can do this notation, but these square braces. This lets you index into a string at this position. We'll learn more about that and see that again in a future lesson. We also looked here at making sure these are the same and these are the same, and we used break, then another word could continue. And break once again lets you escape a loop, so it says while this is the condition. Then if you hit a break, it's like, okay, no, don't check anymore, we're done. Continue on the other end, says, okay, wherever we're at, don't do anything else in the loop, and continue running the loop. I think that's pretty much all I wanted to cover today. At this point, we've covered a lot of topics here at this point. We've looked at our basic setting up a project in C#. We even created one. This one here already had one created beforehand. We've looked at writing to the console, reading from the console. We've looked at conditions, so doing some kind of logic, controlling your program to do one thing or something else. We've also looked at looping, doing something repeatedly, multiple times, what have you. Next lesson, we're going to put these operations into action. We're going to take a stab at a small project. So it'll be similar to this, but a little more in depth. We may even look at one new concept in it. I haven't decided 100% if I'm going to talk about it in the same lesson or not. We may not want to do it. I'll see. But we're going to do a project. And I've heard different opinions if this is a good project or not. I always liked starting with a calculator. Just a little, like a 4-function calculator. So add, subtract, or divide, multiply. And it lets us see some concepts and not be too complex and be an easy enough problem to wrap your head around. So that's what we're going to do in the next lesson. We're going to do a calculator, and it'll make use of these features. Maybe one more. I haven't decided for sure yet, but that'll be next time. So we're going to call it there. Until then, thanks for watching. Have a wonderful day. Signing out.